Alrighty, let's take a look at functions and their inverses 1.4. So, these first ones are dealing with the properties of exponents. Okay? Now, remember, you can only do this if you have the same base, right? The base is that number that's being raised to the power. So the base here would be 3's, bases of 2's, of 7's, and so on. Bases of p's. Okay? Now, remember, with the rules, it basically goes like this. If I've got a to the x times a to the y, that equals a to the x plus y. Right? So we're just simplifying it that way. So honestly, I don't really feel like I need to do any of these because they're that simple. Now, if you're dealing with division, a to the x over a to the y, same basis, ends up being a to the x minus y, to simplify it. So, just going to let you guys deal with it that way. I think you can handle all these type of problems. Okay? Alright, let's take a look at 15. Now 15 gives us some functions, f of x and g of x. It wants us to calculate what their numbers are, remember. So for f of x, we put f of 16 equals the square root of 16 minus 1. The square root of 16 is 4. 4 minus 1 is 3. So f of 16 equals 3. Now g of 3. G of 3 would be equal to 3 squared plus 7. Well, 3 squared is 9. 9 plus 7 is 16, so g of 3 equals 16. So then when it wants you to write it as an ordered pair, think of it as the number inside the parentheses is the x, the other number is the y, the input and the output. So it would look like 16:3. G of 3 would look like 3:16. Okay? So what do you notice when you look at these numbers? Okay, look at these ordered pairs. How are they the same? How are they different? Okay? So what does that mean? Okay, think about what we've been talking about. I'm not going to do the rest of them. I think you guys can do the rest. We'll probably talk about them in class. So try the rest of those. Okay? I want to spend more time on some other parts. Alright, matching. I really want you guys to try this one on your own first. So if you haven't tried it yet, please hit pause and go over the problems. But if you have tried it, then just use this to kind of check to see what you're doing. So some of them would probably be easier to start with. So I would start with, I think these ones are easy to pick out first. Okay, so x to the 5th. So if you still haven't done this, hit pause. Now's your last chance to hit pause. I really want you guys trying this on your own. So x to the 5th. What's the opposite of x to the 5th? Well, the way you undo it is taking the 5th root of x. Okay, that's how we undo it. Same with x cubed. The opposite is taking the cube root of x. So that's another match. Okay, now similarly, number 18, we've got the 5th root of something. So what are we going to end up doing for that inverse? We're going to have to do it backwards and take the power to the 5th. And remember that minus 3, since it's inside, it has to be outside for the opposite. Right? Because we do things backwards. If you guys remember from talking about it in class. Okay, now take a look at number 16 and 21. They look kind of similar, right? Remember, it comes down to that order. Okay, it comes down to that order. So here, we're timesing by x and then adding 5. So, is it going to be this one or this one? Well, think about it in the opposite terms. We times by x just by the 3, and then we added the 5. So to do that backwards, you would have to minus the 5 first and then divide by 3. Which means if we added 5 and then timesed, we would divide and then minus. Okay. So now the only two we've got left are 20, and 22. And it's pretty obviously they're both logs. And hopefully you notice the 5 and the 3, so you just match it up. 5 to the x would be right there, and this one would be right there. Though I actually think this should have, no, I'd have to look something up, but I think there, go with that for now. Okay, so hopefully that's what you ended up with. Okay, now 23 through 30, they're all kind of connected, these problems. The first is finding the composites, where we do the function within the function. So first we're going to deal with that, and I use this separate page for that, and then we'll come back and kind of match with the graphs and talk about these questions. So f of x equals 2x plus 5, g of x equals x minus 5 over 2. So if we're plugging them in, if I'm doing f of g of x, then 2, but instead of x, we put in g of x, so that would be x minus 5 over 2. And similarly, doing it the other way, g of x, we'd have 2x minus 5, or plus 5, minus 5, over 2. Okay? So, when we multiply by something that's dividing, those will cancel out. Okay? And then we're left with x minus 5 plus 5. Subtracting 5 and adding 5 cancel out, and we're left with x. So this one equals x. G of x. Try to that one. Now, the parentheses we can just get rid of because there's nothing multiplying by it. Plus 5 minus 5, they cancel out to 0. 2x over 2 cancels out to just x again. So that one equals x as well. Okay, we can try it with another one. Let me skip and do 26, because that one seems to be a little bit more difficult. Okay, I think you guys can handle doing 24. So, f of g of x would equal negative 3 over, and then we put this whole thing in for x, so it would be negative 3 over x minus 2 plus 2. Okay, so think about it like this. Negative 3 divided by negative 3 over x minus 2 plus 2. Okay, make that a fraction. Remember, we can't divide fractions, so we have to multiply. But in order to do that, we have to get the reciprocal. So we get negative 3 over 1 times that. Multiply across. Negative 3 times x minus 2. 1 times negative 3. Now those cancel out, right? 1 on the top, 1 on the bottom. We're left with x minus 2 plus 2. Those cancel. We're left with x again. You seeing the pattern here? Okay, now let's try g of f of x equals, so we go negative 3 over x plus 2 minus 2. So negative 3 for negative 3 over x plus 2 minus 2. Because there's nothing multiplying the parentheses, those parentheses get eliminated. The 2's eliminate each other. Negative 3 over x. Okay, that is like negative 3 divided by negative 3 over x. Make that a fraction. Flip it and multiply. Notice we've got a negative 3 on top and on bottom, so those will cancel, leaving us with x over 1, which is, once again, just x. So, hopefully you noticed on these two that they came out to be x as well. Okay, that's the pattern you should be seeing in all of these. I'll let you do 24 and 25 on your own and try to come up so they get to be just x. Okay, so we found out that all of those equal x, right? When we plug them into each other. Okay. Now, for these ones, they want us to take these graphs and match them up with them and tell you which one is which. So, if we look at 25, you should notice it's linear, so it's either going to be B or D. And we can graph the first one, 2x plus 5, so the y-intercept is positive 5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So it's going to be, for 23, it's going to be D. And the blue one is going to be the f of x, which would make the black one the g of x. Okay. Now 24 is a cubic one. You should recognize that the only one that has that cubic is C, so it's definitely C. Question is, which one is which? Well, that's cubic, that's cube root. Cube root is sideways, so the black is g of x, the blue f of x. Now 25. Okay, another linear, which should tell you that we're dealing with B. Okay. Now 3/4 x plus 6 would be our y-intercept of positive 6, so f of x would be blue, g of x would be black. Which means for our last one, 26, that's going to be A, and what you should realize is the blue is going to be f of x, and the black is going to be g of x. If you weren't sure, you could just find out when x is 0, and now it'll tell you the asymptotes, which would be another way to do that. Okay, now on 27, it wants you to graph the line y equals x on each of the graphs and figure out what you notice. So, let's go over and make those graphs bigger. Alright, here we go. So now remember, y equals x is simply going to be, and it's going to be hard for me to graph it too well, y equals x has a y-intercept of 0, 0, and a slope of 1, 1. So it's just going to go kind of like that. Okay, on each one of these, more or less like that. And these aren't the straightest lines, but hopefully you can do better. Okay, so it should look something like that. What do you notice? Okay, and I'll give you a hint. Think transformations. Okay. What do you notice here? How the lines are looking. Okay, hopefully B and C are pretty apparent. What would happen if you took this black line and rotated it around the y equals x? Would you get the blue line? That's kind of what it's driving at. And that's hopefully what you're noticing, that each of these inverses are reflected over y equals x. Okay? Then 28 says, do you think your observations about the graphs in number 27 has anything to do with the answers you got when you found f of g of x and g of f of x? Notice y equals x. What did all of our answers come out to equal when we did that? Came out to equal x. Okay. 29. Look at graph B. Shade the two triangles made by the y-axis, x-axis, and each line. What is interesting about these two triangles? So they're saying if you were able to take these and shade them in. Okay. What do you kind of see about them? That's what I want you to write. Then it wants you to do the same thing in graph D and see if it's the same. So, I think that's enough we've spent here. We'll probably talk a little bit about this homework in class because I think there's some things we want to bring out. But I think that should be pretty good for you guys to finish the majority of it on your own.